Honors Physics, Electric Field Strength in the unit of electrostatics. This is day 132 or page 132B of the notes. And I've written down the two equations that are important here for determining electric field strength. These few problems, at least these first three, are more or less plug and chug. And I've drawn the electric field in the flat piece of paper here that would be showing the two-dimensional idea or shape or picture of what the field looks like around a positive charge, this positive blue particle here, a positive 12 microcoulomb charge. But bottom line is, which equation do you use? Well, if you're given a distance, 25 centimeters, you're going to be using equation number 2, the electric field strength at a given distance from a source charge, the source charge here being capital Q. So you just basically plug into that equation. So if you plug the numbers in, make sure you have the right units. 9 times 10 to the 9th is a given, the constant. 12 micro is 12 times 10 to the negative 6th divided by 0.25 meters squared. You end up with a field strength of 1.73 times 10 to the 6 newtons per coulomb away. So they're talking about a location here. They're talking about, like, say I'm like here, 25 centimeters from the blue charge. So that's how strong the field would be. There'd be basically 1,730,000 newtons of force if I put a 1 coulomb charge there. You would never put a charge that size there. That actually would be larger than the charge you started with, but that's the standard units. 1.73 times 10 to the 6 newtons per coulomb, and away would be the direction indicated by these black arrows. All right, in problem number 2, very similar type of plug and chug problem, except for in problem number 2, I'm giving you the force and the charge, no distance, so it's going to be the first equation. Let me plug into the first equation. All right, so I did plug into the second equation, or the first equation, the definition of electric field strength. You have a 2 Newton force divided by 3 times 10 to the negative 6 coulombs of charge, microcoulombs, gives you a field strength of 6.7 times 10 to the 5th newtons per coulomb. So in this case, we know if this green charge right here is 3 microcoulombs, but we don't know what the source charge is here, and we can't figure it out because we're not given enough information. We're not given how far we are from that, so we cannot determine the source charge. But we didn't need to. We just needed to figure out the field strength. And once again, you could say away here. You could say that. So it's away from the source, and that would be the field strength. And then number 3 is very similar. And once again, we're just dealing with this equation because we're looking for a distance from a given source. We know what the charge is. We know what E is, the E field. And the units are good. And K is always known, and Q is our source charge. It's not a particle in the field. It's actually the particle that's generating the field. And we just got to figure out the distance. So it's plug and chug. So there's the setup. The algebra is a little bit more difficult, but not too bad. If you plug it in your calculator, you get that the distance is 37 centimeters, 0.37 meters. I'm just going to say 37 centimeters. And once again, you don't need to draw the diagram. They're just asking for the distance. And that would be it, plug and chug. And now you need to go to the 4th problem. So put on your algebra pants for the next one. And vector diagrams and components, all very, very important in this next one. So hang on to your hats. Enjoy the ride.